Hey guys, welcome to Unshackling Sudokus and Puzzles. I'm Kishore, and today I'm going to solve a Killer Kropki Pairs Sudoku created by Joseph Nehme. The link to solve this Sudoku is given in the description of the video. Please do give it a try and come back and watch the video. The rules are simple. Classic rules apply. Each row, each column, and 3 by 3 box of the grid will have digits from 1 to 9, no repetitions. Killer rules apply. In each of these cages, the sum of the digits will be equal to the clue given in the top left corner, and digits do not repeat inside cages. And finally, Kropki pairs rule applies. So on either side of this white dot, you will have digits which differ by 1, and on either side of this black dot, you will have digits which are in the ratio of 1:2. For example, you can have, let's say, 2 and 4, or 4 8, or even 3 6, and so on. And the final part is that not all possible dots are marked. So for example, you may have, let's say, 2 and 3 here without a white dot in between, or a 3 and 6 here without a black dot in between, right? So these are the rules, and the title of the Sudoku is O O O and O O O, and that is probably because of these cages, right, which resemble 6 O's. So the original version of this puzzle had colors given in it, and I had chosen the version without the colors. So you can see that there are 6 O's in the grid, and that's why probably it is titled that way. So let's start this Sudoku now. Okay, the first idea that I get is, I know that in rows 2, 3 and 4, I have 3 sets of the digits 1 to 9, which sum up to 135, right? Because when you take a row or a column or a box, you will always have digits which add from 1 to 9, which is equal to 45. So when you take 3 rows together, so rows 2, 3 and 4, so it is going to be 45 multiplied by 3 times, right? So which means that from these 3 rows, from all the cells shaded in yellow, we have a total of 135. Now I'm going to add all these cages and get the total of these 3 cells which are not inside cages, the red cells, I mean, right? All the cells except the red cells are in cages. So I'm just going to add the digits in cages and subtract uh, those total from 135. So I will get the sum of these 3 cells, and I'm going to do the same here because that's the only idea I'm getting seeing this grid. Okay, 23 plus 15 is 38, and 38 plus, you have two 19s, 38 again, so that is 76, plus 16 is 92, plus 19 is 111, right? So 35, adding the cages total again, 54, 73, and this is 96, and this is equal to 111, right? So which means that these 3 cells, if I subtract 135 from 111 from 135, I'm getting exactly 24. That is really nice. That is really nice, because I know that 24 from 3 cells can only be achieved in one way, which is by putting 7, 8 and 9. And now this black dot comes into play. You can never have 7 and 9 on either side of a black dot, because then you must either have 3.5 or 14, or 4.5 or 18. So that is not possible in a Sudoku. So that's 8, that's 4, which means these two are 7 and 9. And since these two cells are consecutive, this must be 6 or 8. If it is 7, it is 6 or 8. If it is 9, it is 8. Similarly, this also is 6 or 8. So we got a nice start to the Sudoku. Now let's do the same thing in these 3 rows, rows 6, 7 and 8. Just highlight those rows. Okay, and I'm going to get the sum of these 3 cells which are not inside the cages. Again, the same idea. I know that these 3 cells must be 135 minus the sum total of all these cages, right? Because these 3 rows add up to 135. Let us do that now. So 13 plus 21 is 34. 34 plus 15 is 49. Plus 18 is 67. And then we have 25 more, which is 92, and 23 more, which is equal to 115, if I'm not wrong. Let me add this once again. 48 from here, 66, uh, 81, and 102, and 115. I'm pretty certain. So 135 minus 115 would give you the total in these three cells, which is equal to 20. So 20 is not so uh, restrained as the 24 we obtained here. So 20 can be obtained in many ways. For example, it can be 389, it can be 479, it can be 569, 578. Uh, yeah, there are how many ways? Four possible ways to get the 20. So I don't think we'll be able to do anything now. Let's see with this cell, because this is having a black dot here. This must be very constrained. So we can't have 1 and 2 here and 5, 7 and 9 here, because obviously you cannot reach 20 with 1 or 2, and 5, 7 and 9 are eliminated because they won't be able to satisfy a black dot. So this must be 3, 4, 6 or 8. Okay, I can't have 3 here, can I? Okay, because if you have a 3 here, then these blue cells add up to 20, remember. So these two cells must be 8, 9 pair, because you have 8 here. This becomes a 9. And now to satisfy the white dot, you will have an 8 here again, which is violating the rules. So 3 is eliminated from the blue cell. That is useful elimination, I think. So if I have a 4 here, this becomes 7, 9. And is that helping me? That seems to be possible. So if I could somehow prove that 9 is not in any of these three cells, then I would have only one possible combination for the 20 sum, which is 5, 7 and 8. There's no other way to make a 20 without a 9. So I know that 9 cannot go here because that would violate this one. Can I make sure that the 9 doesn't go here as well? 6, 7, 9, 8. I don't think I can be able to do that easily. Okay, let us just go back and think a little bit about this clue. Okay, so we obtained a 4 here, right? Can we make use of this uh, digit here? So these three cells sum up to 19 now, and 19, okay, there are many ways actually for 19. So we really need the digits in blue cells. I don't think we can be able to do much without that. But really a nice design, guys. I'm really enjoying the solve. Okay, 9 and 8. Okay, let us go one by one. I don't see any other possibility. If you have a 4 here, um, then these two cells are 7 and 9. Obviously, you can't have a 9 here, so that would be a 7. Uh, Let us see. It's a 7. This would become a 9, so this would be 8 now. This would be 6 and 7. This would be 9 and 8. Okay, this would be a 6. Sorry. Okay, so because I have an 8 here, so this becomes my 8 now. And 9 can't go here, so 9 would have to go here. So this is 7 and this is 6. So let us think at this point. If I'm trying to see if I can eliminate one of the digits from here. So if I have a 4 here, this is my only setup of digits. And now this would have to be a 2, because to form the ratio of 1 is to 2, this becomes a 2. Now the 25 is 6, 8 and 9. So that's a 9. That is 6 and 8. So I don't see any problem with that. And it is working perfectly well. Mm, am I missing a trick here, guys? Okay, I don't see any contradiction here. So this is a perfectly valid setup. I'm just making sure that this setup is not contradicting before we try to eliminate other options. Okay, I'm comfortable with this setup. So let's go back and see if we can maybe uh, try eliminating 6 or 8. So if you have a 6 here, this becomes 3, this becomes 8, this becomes 6, 6 would have a 7 and this would have a 9. And now if you have a 6, these two cells must sum up to 14, which can be only 9 here and a 5 here. So which means this would be 8 and this would be 4 or 6, so this would be a 6. Okay, so if I'm not wrong, when we had a 4 here, we had a 7 and a 9 here, and in the first case too we had 6 and 8, right? The exact same as what we are having now. So if this is 4 or 6, this would have to be 6 and 8. There is no change in that. So we can remember that. Now all we need to do is what happens with the 8. So we already saw that if this is 6 and if this is 8, we didn't have any problem. So we got a new digit here, 3, right? Which means these 3 cells sum to 22, 985 or 976. Both are possible. Okay. So if this cell is 4 or 6, this and this becomes 6 and 8. There is no change in that. Now let us try with the 8. I'm going to remove these cells and try uh, with the 8 in that cell. Let's see what happens if this is 8. So which means this would become 6, that would become 8, that would become 7, that would become 9. Now I'm sure that I can't have 9 in both of these cells because 9 is eliminated due to this dot, and because of the 8 being here, 9 is again eliminated. So when you have 8 here, the only option left to us is 5 7 and 5 7. So So if I have 5 or 7 here, what does this become? This again becomes a 6. Wow, that is wonderful, guys. Really wonderful deduction. Really deep one, very deep to see. And it's so much fun to find this during a live solve. So we have seen here that if this is 5, this would be 4 or 6. But 4 can't go here, so 6 would be here. And if this is 7, this would be 6 or 8. Again, 8 can't go here, so this is 6. So regardless of whatever goes in row 7, column 8, row 6 column 2 is always 6. What a deduction, guys, what a deduction. So which means I can blindly erase off these digits and put a 6 there. Really deep one to see. So this is always a 6. No matter what you put here, this is always a 6, and that is really remarkable. And now we know the contents of these 3 cells, right? Let me remove these corners. So 7 from 3 cells is only 1, 2, 4. 4 can't go here, so 4 is in one of these 2 cells. And now the 15 suddenly comes into action, because I'm able to see that the minimum possible sum that you can get from these 3 cells is 356, and that gets you to a total of 14, and which just about leaves you enough room to place 1 and get to the total of 15, right? There is no other option. So when you have 6 here, this is 5 or a 7. There's no nothing to think about there. And now let's look at column 1, the remaining digits. This is 7, 9, this is 7, 8, 9, and this is 7, 8, 9. Okay, so we've got a good continuation here. So 6 is in 6, 8 pair is here, so that's not a 6, which means this is not a 6, which means we get a 6 in one of these 2 cells. Okay, I think we can make use of this 23 now. So we have seen here that 8 is in these 2 cells. One deduction which I didn't spot was that we could have deduced that 9 is going in these cells. And how is that? Because these 3 cells add up to 19, you must have either a 9 or an 8 or both. You cannot reach 19 without 8 and 9, because the maximum sum would be 7, 6 and 5, and that's not going to take you to 19. So this must have an 8 or a 9 or both. 8 is not in this cell, and 8 is not in this cell due to this 6, 8 pair. So which means 9 is going here. 9 is not here because of the 7, 9 pair. So we have 4 plus 9, 13. We need 10 more, which cannot be 1 plus 9, which cannot be 2 plus 8, which cannot be 4 plus 6. So it would only be 3 plus 7. This could have been deduced much earlier, guys. Sorry for that. 7, 9 is here, so that is a 3, not a 3. And this 3 removes the 3 from here, giving us a 5, 6 pair, so that is a 3. Okay, so and now in box 4 we get one more pair. This is 2, 4, because 7, 9, 5, 6, 1, 3, 8 gives a 2, 4 here, and this 4 gives me a 4 and a 2 here. 1, 2, 4, 6 and 8. So we need 3, 5, 7, 9 in the remaining cells. You have 3 here, so that is 5, 7, 9, and that gives you a 3 in here. Okay, so I can see here that the 3 cannot go here. By using arithmetic I can reduce that. And how is that? So if you have a 3 here, these 3 cells sum up to 18. I'm going to highlight that again using a different color. I'll switch it back. So if these 3 cells add to 18, and we know that these 4 cells are summing up to 23, right? So 23 plus 18 gives me 41, and this column by itself adds up to 45. So these 2 cells marked in pink or even light yellow, I'll go with pink. So these 2 cells marked with light pink must be 1 and 3 to get to 4, but 3 is already in that column, so you cannot have a 3 in here. That 3 goes here. So which means this would be 579. So what was the other digit that we got when we had 4 or 6 here? I think this was an 8, right? Regardless of whether we had 4 or 6 here, this was always an 8. Let me quickly check that again. If this is 4, this becomes 7, 9, so this would be 8. And if this is 6, this would have to be 5, 9, so this is 9, this is again 8. Okay, so if this is 8, this becomes 5, 7. So let me write the possibilities here. So this is 8, but if this is 8, this is 5, 7, in which case this would become 4, 6 or 8. Can't be 6, so this would be 4 or 8. So this is the exhaustive list of digits that can get here. It is either 4 or 8, no other combination. So can I make use of arithmetic to deduce some digits here? Seems likely, but check. Can we have a 5 here? This becomes 16. 16 plus 23 is 39, so I need one 5 here. This would be a 5, this would be a 1. Seems likely. But if this is a 7, this becomes 14. 14 plus 23 is 37. And I need 7 more from here. Sorry, 8 more from here. Which cannot be 1, 7, which cannot be 3, 5. So this would have to be 6, 2. Which is again possible. Seems likely. So let me write the pencil mark. So in the first case we had 5 here, so which means this would be 5, this would be 1. In the second case, if we had 7, we need 6, 2, so in which case this would be 6, this would be 2. And if we have a 9 here, these become 12. 12 plus 23 is 35. So we need 9 from these cells, which cannot be 1, 9, which cannot be 3, 7, which cannot be 4, 6. So this must be 2 and 8. And this would be 2, 8. That would be 8. So all are possible. Looking for some elimination that didn't help me. Okay, so now that we have written the possibility here, so this can only be 3, 5, 7, 9. Of course, 3 is eliminated because you would need 8, 9 here. This is 5, 7, and 9. Okay, I think we need just uh, one more deduction to get us going here. Six, 7, 9, 8. Not seeing anything here actually. Okay, we can eliminate the 7 from here, minor reduction, because if this is 7, this becomes 8 and you can't have a valid dot here. This would be 6 and this would be 9. So 8 is not here. And this is not a 7. So this is 5, 9. Okay. It's a tough one, guys, but really interesting. Wish I could decipher something from here. So 2, 4 are going into these cells, and 2, 4 is going into these cells. Can we make use of that? Okay, I think I'm just going a bit ahead. I think I need to focus on here only. Not sure why I'm this 8, 6, 3, 6. Ah, I'm really missing something here. What is that? Missing here. It's not easy to get this total. If we get this total, I think we should be able to see it fast. Oh, I can't have an 8 here, guys. If this is 8, this becomes 4, and this would be 8, so this would be 9. Now 8 plus 9 is 17, and you can never get a 3 here because 3 is already here. Oh, that was good. So this is not 8, so that's 4 and 6, which means I can write some possibilities here. This is 2, 8, or 3. Maybe I can just do something with these kind of things. Uh, if this is 8, look what happens again. This becomes 4, so this would be 5, and because of this is 8, so this would be 4. So 4 plus 5 is 9. So because of the interaction in row 6, we're able to get some eliminations going. So 4 plus 5 is 9, and you can never get to 20 from these cells. So 8 is also eliminated from here. So which means that this is only 2 or 3. That's good now. And now I know that this is either 23 or 22, depending on whether this is 2 or 3. So in both cases 9 must be going here. So it is 689, or it is 985 or 976. Okay, exhaustively speaking it's 56789, right? How did this stray 6 got here? So I don't know, just remove that. So still it is playing around with us, not giving a digit. Hmm. What happens if I have a 6 here? That becomes 4, that becomes 2, should be 689, 7. Ah, this is really workout, guys. Okay, let's go with 3, 6 here. This would be 5 and 9, and this would be 8. So you have 3, 8 here. This would be 8 and 9. This would be 6 and 7. Don't know. No contradiction in either of these cases. Okay, one thing I notice is that 1 must be in one of these two cells. A pretty useless deduction for now. Maybe there is a simpler way to look at the things here, but I'm missing that. So if I have 8 here, this becomes 1, 2, 4. And unlike here, I don't think we can do anything with the 19 cages. 19 is pretty huge. So 1, 2, 4. There are still many ways to satisfy the 19. There's some global logic I'm missing here. This is a tough one, guys. Really tough one, actually. How many minutes the video is gone? 30 minutes. Sorry, I'm going a little bit slowly, I think. I'm unable to see anything here. Okay, so if I look at this box and ask myself where the 1 and 2 goes, they're pretty limited in possibilities. So there are only 3 cells left for the 1 and 2. Now if I assume that this is not 1 and 2 and this is 1 and 2, let's see what happens. This becomes a instant 3, so this would be 6, that would be 5, that would be 9, and that would be an 8. So 8, 7, 9, 6, 7. So this would be 1, 2, 4, so that would be a 4. This would be 1 and 2. 5, 7, 9 would go here. I don't see a problem with having a 1 or a 2 here. This could actually be a 1 or a 2. So let's just go back. I'm sorry, I'm having lots of staring at the grid for a long time, but not getting something here. How am I supposed to tackle this? Really, I mean, right at the start, I'm stuck and I'm unable to find anything, guys. Sorry for this, really. I just can't see a way by which this can be resolved, really. This should have been resolved by now because we have got all the important things, but I don't know what I'm missing here, really. 2, 3, 6, 5, 9, 8, 6, 7, 9, 8. Okay, think here. 6 and 8 add up to 14, which means these three cells, they sum up to 38 minus 14, which is 24. So these three cells sum up to 24. I mean these 6 cells. The ones I've highlighted just now in green, they sum up to 24. That useful. Um, oh, okay, there's one more small thing here. Uh, all these 19 cages and all these 23 and 18 cages, I'll just use a different color, maybe black. All these 4 cages, sorry guys, black is not get good. Just change the color. Black completely removes the total. So maybe what is this color? It's indifferent. Okay, so these 4 cages, the L-shaped cages, they add up to 41 plus 38, right? 23 plus 18 is 41, plus 19 is 60, plus 19 is 79. And we know that these cells sum up to 24. I'm trying to do here, I'm not certain. I was actually hoping we could get the sum of these two cells. It's not to be, I think. Am I missing some rule part here? Why struggling here? Make it back to original colors. This is bad, guys. I don't know why I'm missing this certain. Probably some easy deduction which I'm really missing here. Let's see once again what happens if this is 4, this is 4, this is 2. Then this would be 7 and 9. That is 7, that is 9, that is 8. And which means this would be 8 and 9. This would be 7 and 6. This becomes 1, 2, 4. Okay. Okay, let's see here. So this 2 gives a 1 here. And that 4 gives a 4 and a 2 here. So this would be a 4 now. This would be a 2 now. That would be a 1. I'm just blindly going along here. Let's see what happens. Here a 23 from here, so this would be 6, 8 and 9. That's 9. Be a 6 and a 8. Again, doesn't seem to break, so okay, I'll just revert back. Not breaking. Let's try with the other guy. Let's go with a 6 here. That becomes 3, which means this would be 5. That would be a 9, and that would be, oh, didn't we get an 8 in the earlier case also? Oh, so when we had a 4 here, we had a 7 and a 9 and an 8 here, and when we had a 6 here, we had a 5, 9 and an 8. Oh, I missed this, guys. I really missed this. I'm extremely sorry for this. I don't know how I missed this. Really means, not sure. Both the cases, this is a 9 and 8. How did I miss that? I'm sorry for this, guys. That was really bad solving from me. Not sure how I missed that. If this is 4, this is 7, 9 and 8. And if this is 6, this is again 5, 9. So in both the cases, this is always a 9. Damn it. It was such an easy deduction and I just missed it. That is 9 and 8 now. So I promise to solve it quickly from here, provided it goes well from here. So now you have 8 here, so this is always 1, 2, 4. And can I do something here? Okay, we have 6, 7, 8, and 8, 9 here. This is not 2, 4, so that's 1, 3, 5. If now what? So this is equal to 11 and this is equal to a 13. 19. It's really restricted. Okay, we have 1, 2, 4 coming along this column. And we know that 19 cage does not take a 1. Okay, the 2, 4 in box 2 goes in these two cells. These three cells. Is this really harder Sudoku or I'm messing it up completely? I know I just messed up this part. I should have found this way longer, but again it seems to be tough here. Or what I'm missing. Nine is not here. This is 4. This is 2. This is 9. This would be 6, 8. This is 3. This is a 22. Means this is 985 or 976. And both seem possible. Okay. So I'm seeing something here, guys. These yellow cells must take a 3 in here. Because if they don't have 3 in them, we know that they already don't have 1, 2, 4 in them. So 1, 2, 3, 4, and which means the minimum sum here becomes 5, 6, 7. And now you can't satisfy the 19 because the minimum value here would be 2, and 2 plus 5 plus 6 7 plus 7 is never equal to 19. So there is the 3 definitely in here. So 3 can't be here, 3 can't be here. So 3 goes here and the 3 goes here. Now probably we can play around with digits here and get something. So look at this row and this column. Look at this cell. 3, 4, 6, 8, 1 and 2. So this is 5, 7, 9. And what is this? 3, 7, 8, 9, 1, 2 and 4. So this is 5 and 6. Oh, that is beautiful, guys. We got a 5, 6 pair. A sight to behold after such a hardship. 1, 2, 4, 3, 7, 8 and 9. So this is 5, 6. So these cells are 1, 2, 4. Now So now I can do some elimination here. This is not a 5 as that would force a 6 here and we would require another 5 here. But digits do not repeat inside cages, which means this is not a 5. That's a 7, 9. So we have a 7, 9 pair. 3, 4, 7, 9, 6 and 8. So which means these cells are 1, 2, 5. So probably we can do some summation here and get the sum of all these cells. But I'm thinking whether it is really worthwhile to do that. So let's see. 6, 7, 8, 9 and 1 and 3. Look at this cell. These are the exhaustive list of candidates here. 2, 4 and 5. Nothing else. If this is 5, this is 6. 5, 6, 3 is 14. 5, 6, 3 is 14 and you would require another 5 here. So this is not a 5. That's a 2 and a 4. So if I have 2 here, 2 plus 3 is 5. I would need 14 here, which would be 5 and 9. If I have 4 here, this is 7. I need 12 more from here, which can be 5 and 7. So I don't think you can have a 6 here, right? So let's say you have a 6 here. Can we get to the total? 3 plus 6 is 9. We need 10 more from these cells. We don't have a 2 and 8. We don't have a 4 and 6. Superb. So this is not a 6. This is always a 5. That's good. So that's a 5. That's a 6. That's a 5. and 8. We need 11 more from here, which can be 2, 9 and 4 and 7. Both are possible. Okay, 5 goes in here by classic. So if I look at this column 4, 1, 2, 4, 3 and 5. Look at this cell, it can't be 6 and 8. So that's a 7 and 9, which means I can place 6, 8 pair in this column. So probably this would help now. I can play around with some bits here. Okay, I can't have 2 here, because if this is 2, 2 plus 6 is 8. And now the we know the 2, 4 goes in these 3 cells. So if you have a 2 here, the 2 goes here and pushes the 4 here. Now 2 plus 4 plus 6 is equal to 12, and that would require a 7 to make the 19. So you cannot have a 7 here. So that's not a 2. Okay, so the 2 goes in here. Beautiful, guys. The deduction we have been looking for all while. So finally we have been able to decipher this. This is not a 2. That's a 3. That's a 6. 6 plus 9 is 15. So that's a 5, which means that's a 7, 9. And we have a 7, 9 pair here. So that is 8. That's not an 8. So 7, 9. 7, 9 here. Okay. So this is not 8. 6, 7, 8, 9, 3 and 4. So this is 1, 2, 5. Okay. Getting somewhere here, I think. 3 goes in here. Classic. Okay, I think we can do some elimination here. If this is 7, this becomes 14. 23 plus 14 is 37. So we need 8 more from here, which cannot be 1, 7 and 3, 5. So this would be 2, 6. In which case this would be 6. Sorry. This would be 6 and this would be 2. And if you have a 9 here, this becomes 12. And 23 plus 12 is 35. So we need 2, 8 here. So this is always 6 and 8. This can never be a 5, guys. This can never be a 5. Look what happens if this is a 5. This would be 7 or 9, right? You can never satisfy this total. So let's put a 7 here. So this instantly becomes 14 from these 3 cells. And these 4 cells add up to 23, as we already saw in the beginning. So 23 plus 5 is 28. And 28 plus 14 is 42. So you don't have a 3 here. And if this is a 9, these add up to 12. And 28 plus 12 is 40, and you will again have a 5 here, which is not possible. So that is a 2, and that gives 1 here, a 5 here. This becomes a 2, 4 pair, and we already have 2, 5, 3, 4, 7 and 9. So this would be 1, 6, 8. Can't have a 6 here, so that's 1 and 8. And we have a 6, 8 pair here now. So 8 is not here in these 3 cells, 8 is pushed here. And now we know what the contents of these cells must be, surely, right? We have 3 here, so these cells sum up to 22, which cannot be 6, 7, 9, because 6 is here and 6 is here. So this must be a 9, 8, 5. So that is a 5, that is 8, and that is 9. 5 is not here, not 1. So 1 goes here. 1, 5, 6, 8, 3 and 9. So this must be 2, 4, 7 and 2, 4, 7. But we have a 7, 9 pair, so which means this is not 7, so that is a 7. So 2, 4, 8, 6, 7, 9. So we need 1, 3, 5. So that is 1, 3, 5. Now probably we know what these add up to. We have a 7 here and a 23 here. So these add up to 16. And 3 must go inside, because can't have 3 in row 9. 3 goes here. Now we need 13 more from 2 cells, which cannot be 5 and 8 and 6 and 7. So these must be a 3, 4 and 9. Can't have 9, can't have 3, so that's a 4. That's a 3, 9. This is not a 4. Oh, this 2, 4 could be resolved. That's a 4, that's a 2. And now this cage could be placed. So 4, 2, 1. And this is not 1, that's 6, 8. That places the 1 here. So we have 6 from here, which means this is 15. And there is no way to resolve that. Okay, 3, 9 could be resolved because of the 9. So 9, 3. Row 7 can be filled. That's a 5. Oh, sorry guys. 1, 2, 4, 5, 9, 3, 6, 7 and 8. That's a 7. Okay, 4, 5, 9, 3, 6, 8. So these must be 1, 2, 7. 7 can't go here, so that's 1 and 2. This 7, 9 gets resolved. That's 9, that's 7. That's 9, that's 7. That's 9, that's 7. 7 gives a 9 here, a 7 here. And 4 here gives me a 2, which means these two cells must be known. 2 plus 7 is 9. We need 9 more from here. Cannot be 1, 8, 2, 7, 4, 5. This would be 3, 6. And because of the 6 here, so that is a 6 and that is a 3. And that resolves the 6, 8 now, which resolves this 8, 6. 1, 3, 6, 8, 2, 7, 9. So we need 4, 5 here. Okay, so what next? 19 cages almost filled. 17 from these 3 cells, so that is a 2. 3 here removes the 3 from this cell and this cell. The 1, 5 pair gives me 4 and a 5 here. And 1, 5 pair gives me a 3 here. 5, that's a 5, that's a 1, that's 2, that's 5. So we need 1, 4, 6 here, 4 and 6, so that's a 1. Means this would be a 4 and a 6 here. 1, 3, 8, 9, 4 and 6, so we need 2, 5, 7. So 2 is in row 1, row 2, so that gives me a 2 here, a 5 and a 7 here. And this is 1 because need 1, 7 here. That's 7, that's 1. And 2 can't go here. So 2 plus 7 is 9. We need 7 more, which can be 1 plus 6 or 4 plus 3. Oh, 4 plus 3 is not possible because of the 3 here. That's 1, that's 6. 2 is here, so that is 4, that is 2. 1, 4, 6 is 11, so we need 8 more from here. And that's a 1, that's a 9. That's a 3, that's an 8, that's a 4, that's 4, and that's 6. And with that, we have completed this uh, Sudoku by Joseph Nehme. Really enjoyable Sudoku. A bulk of my time that I took was finding that this is always a 9. I don't know why I missed that. For some reason, I could not gather that this is always a 9 and hence this is always an 8. And with that, we got a lot of digits. I hope you guys enjoyed watching me solve this excellent Sudoku by Joseph Nehme. I really had fun solving this Sudoku. Please put a like and a comment under the video, otherwise this video is going to get lost in the sea of videos in YouTube. Please do think about it and please subscribe to the channel. Thank you. Bye bye.